Assalamualaikum and hi everyone. This is the topic of bilinear transformation for ESE 563 digital signal processing. The linear outcomes for this topic is to apply bilinear transformation in mapping analog digital IIR filter. Slides used in this video are based on the monograph by Dr. Hazli Hashim. The bilinear transformation is a rational function that maps the left half S-plane inside the unit circle of Z-plane and maps the j omega axis in a one-to-one manner onto the unit circle. So the bilinear transformation corresponds to replacing S by this function into the frequency response in S domain. So we replace S with this function, and this is the frequency response in Z domain, where in this case as Ts is the sampling period. Next one, we can obtain Z by rearrange this equation into this one, and we need to replace S equal to sigma plus j omega into this function. After we replace the S function with this equation, we have this one, and we can determine the magnitude of Z and phase of Z function. The next one, if the value of sigma in S domain is lesser than 0, meaning that it indicates for any pole on the left half of S plane. If sigma is lesser than 0, then the magnitude of Z in Z domain is smaller than 1. Then the Z plane must be inside or within the unit circle for magnitude of Z smaller than 1 for any value of omega. Similarly, if we have the sigma value in S domain larger than 0, then in Z domain, the magnitude of Z larger than 1, meaning that it is outside the unit circle, and in S plane it is the pole on the right half of S plane. Therefore, to demonstrate j omega exists on the S plane and maps onto the unit circle, we need to substitute S with j omega. So this is the j omega that we substitute S function. So we have the magnitude of Z domain and the phase of Z domain as written here, and after we rearrange and simplify this equation, we have this one where the magnitude of Z function is 1 and the phase is this one. Therefore, the magnitude of Z function is equal to 1 and the phase omega is equal to 2 arctangent, the sampling period Ts divided by 2 multiplied with omega. Alternatively, if we rearrange this equation, we can determine the value of omega equal to this equation, 2 divided by the sampling period Ts, tangent of omega divided by 2. So with respect to the preceding equation, therefore, the range of frequency that need to be calculated is between 0 to infinity, that we maps to 0 to pi, while the range of frequencies from negative infinity to 0 maps to negative pi to 0.